Good evening, everyone. It is once again Ted the Speed Learner, and tonight I'm going to present the topic of graphene. What is graphene? Well, you're about to find out. But before you do, I'd like to let you know that I have published 5 Kindle books, and if you're interested in purchasing any of these Kindle books, leave me a comment down here in the comments below, and I will send you a link, and you can buy them. Alright. Here we go. If you attended school in the latter half of the 20th century, you would be familiar with pencils made out of a material called graphite. Anyone who used these pencils to complete school assignments may think that graphite and graphene are the exact same thing. Graphite is derived from graphene is derived from graphite. Okay? So, they are very similar materials, but they're not exactly the same. I'll explain this as I continue this presentation. The first thing I have to do is introduce you to a person. The name of this person is Sir Benjamin Collins Brodie. He was a British physiologist, and he performed surgeries during his career. He worked as a surgeon at St. George's Hospital in London, England. Sir Benjamin Collins Brodie wrote a book entitled Pathological and Surgical Observations on the Diseases of the Joints. He carefully examined tissues that form joints to try to determine the early onset of joint diseases. He probably had a unique understanding of arthritis. Sir Benjamin Collins Brodie also became the president of an organization called the Royal Society. Now, what's the Royal Society? Well, this particular society was created in 1660. This society was and still is comprised of a group of people who are experts in science and medicine. So why do you have to know so much about this guy? Well, it's mainly due to his son. And his son, if he was living here in the United States, would be called Sir Benjamin Collins Brodie Jr. However, because he was born in Great Britain instead of the United States, his name became Sir Benjamin Collins Brodie II Baronet. And if you want to know anything about baronets, you can look them up. Okay? So, what did this Sir Benjamin Collins Brodie II Baronet create? Well, he was an expert in chemistry. In his early career, he studied beeswax and presented a research paper to a university in the town of Gießen, which is located in Germany. He won some awards for this particular research. But later in his career, he discovered graphite acid. He thoroughly described the lamellar structure of thermally reduced graphite oxide. If you have no idea what I'm talking about, well, let's go on. The word lamellar, and if I'm mispronouncing that wrong, please correct me, comes from the Latin word lamina. Ah, ever heard of a laminate? There you go. Now, this lamina means some kind of a thin plate. Have you ever laminated something? There you go. So in this case, someone has formed a thin plate of graphite oxide by using heat. But we still don't know the whole story about graphene, because graphene is what we're looking for, not graphite. Now I have to introduce you to 2 more people. The name of the first person is Peter Debye, and the name of the second person is Paul Scheer. Both of these gentlemen lived in Germany in the early 20th century. They developed something called powder diffraction. You're like, what the heck is powder diffraction? Well, let's get into that. The word diffraction comes from the Latin prefix dis, which means apart or to separate, and the Latin verb frangere, which means to break. So you're literally breaking things apart. Peter Debye and Paul Scheer used X-rays to eradicate a fine powder of various solids. This technique was used on graphite. It is this discovery that led to the discovery of the structure of graphite. But this was not the end of the story. Shortly after World War II, a man by the name of P.R. Wallace developed a theory. He theorized that a substance called graphene actually existed. The invention of the electron microscope led to the confirmation of P.R. Wallace's theory. Graphene is only 1 atom thick, but it's very, very strong. It can be used for many things. But I will discuss graphene in batteries in this particular video. Now, you got to keep in mind that graphene is not only very, very strong, but it's also flexible. That makes it ideal for batteries. If you owned an electron microscope, you would be able to see a layer of graphene. Layers of graphene look like a honeycomb. That material can conduct electricity. That means it can send electrons from one point to another. It can also send heat from one point to another. So graphene definitely has its uses. Graphene is very flexible, but it's also very strong. It also has a very low atomic mass. That means if you had enough layers of graphene, you could easily carry them in your pocket. Ooh. Graphene can store electricity just like a capacitor can, but layers of graphene can be charged very quickly, and they can discharge electricity also very quickly. Graphene can also store electricity, and it can store it safely. That's because it can disperse thermal energy. So it sends the thermal energy out, and then you collect it for somehow and you ship it somewhere else. Maybe you have a fan around the graphene. The graphene sends the heat up, and the fan sends it on its way. Okay. The only downside to graphene is that due to its size, it's difficult to produce graphene inexpensively. I want you to research this topic further, and feel free to leave me comments about your thoughts on this topic in the comments section of this video. Alright, I will tell you more in a future video, so I'd like for you to stay tuned.